Okay, let me just, so we've done now problem solving, and now we're going to move on to unit 4, which is about passive attachments. And so let me justify. So we have a little robot here, which is great. Okay, just as a baby robot, it's fine. Okay. But it can't do much. All right. So if this robot were to go and fetch a whole lot of jelly tots, the jelly tots would go here between the wheels. If this robot had to pick up a slab of chocolate, oh, it can't. Okay. So yes, we've got a robot that can move, that can navigate forwards and backwards. Woohoo! But now we want more. All right. You have to understand this is a process, and if you stick with me, we'll get there. Okay. So what we're doing is there are 2 types of attachments that we attach to the robot. Okay. The one is just, it's called a passive attachment, which we're going to do now. And the passive attachment is really to up the functionality without requiring additional programming. That's the one. The other one is powered attachments. And powered attachments are much like this kind of, there's a motor here, and it's linked to gearing. And we're going to do that in M2. All right. So this you can then program. It's a motor, so you can program it in rotation to go up and go down. So you can then program this motor to rotate faster or slower, controlled or not controlled by gears. This one is controlled by gears, so it's got it holds its shape, so it doesn't just go down. It actually holds, because it was quite heavy what this poor robot had to carry. All right, but over here, oh, there we go. Here is the motor, the extra motor that you have. Okay, so this is power attachments. Let me give you another example, and maybe this is not quite as obvious, and we'll get to it when we get to M2, but you must just keep it in the back of your mind. So this has got gears here, which come out of the chassis. All right, and I will show you exactly how we do this. But if you see, I don't know, can you see it from this side? No, you can't. So they're the 2 motors that are used for navigation. And oh my goodness, I can't get it out here. But inside, I don't know if you can see it. Inside there are 2. There are 2 medium motors linked with axles, and so that is also a way of doing powered attachments, because you just clip on the attachments onto the front here, and then with the meshing of the gears, this will then turn, and so you can use that as a powered attachment. All right, but now we're just going to use passive attachments. And so passive attachments are like a bumper. All right, you just stick it on the front of a bumper. You could maybe take this robot, put an attachment on here, and then you've got you can pick things up or collect things. Or so if you put it this shape in front of your robot, you will plow through things. But if you put it like this, then you're actually going to sweep up things. All right, so that's just an attachment that you add to the front of your robot. Now I've got a couple here in my box. Okay, so this is one of my favorite passive attachments. All right, so this you'll see here on this bracket here, we attach that to the top of the robot. So you understand that there's no programming involved in this. The robot just is going to move forward. But this is your pivotal point, and it's just levers. All right. So if you press this, you see that this is going to tip. It's your pivot point. It's straightforward pivot point. So you can put something on here. You can carry it. You can put a whole lot of jelly tots up there. I think Jelly Tots needs to sponsor me. And then if you hit this, it'll tip and it goes down. All right. This is a passive attachment. There's no motors connected to this one. All right. Very similarly, we had this, which was a box, and it was a connection. We had to transport a whole lot of little pieces. All right. So then you can put it all in here, and you just push it, and then it stays there. Okay. It's a passive attachment. There's no programming involved to increase the functionality of your robot. All right. Now, what is important, and you hear, is what is the verb? What does your robot need to do? All right. Do we need to collect? Do we need to separate? All right. Do we need to deliver? All right. In each case, it's the verb, and for that verb, we need to add a structure, and this, in this case, the structure is then your passive attachment. Okay, all right. So let's do. I'm going to show you the structure, and I'm going to share my screen. Okay, so now we're going to go passive attachments. Now you can see just above passive attachments is EDP. And I'm glad that you are, Thomas, I'm glad that you're using Bricklink Studio. And it's about design. Okay, very, very important that there must be a design. But here, the other side, the flip side of that is our students don't have in their heads a frame of reference for designs. Okay, so we need to encourage that. When we build robots, we need to encourage them to design. So either use from an existing design and then modify it, or if they go totally on their own design, then try and capture that. And that is really a good way where we use the engineering design process. All right. So unit 4 is like, woo, here we're going. So we did in unit 2, we did the basic building of a robot. That was the chassis. Now we're going to add things to it. Okay. And we've got two different. We've got the passive attachments, or we've got the powered attachments. And trust me, there are many resources for designing and building attachments. I promise. Okay. But there are steps. It's much like building a house. You can't first put the roof on and then build the foundations. There are steps. Okay, so you burst the foundations, then you pull up the walls, then you put the trusses up, and then you put the roof on top of that. It's much like the engineering design process. All right, except with the engineering design process, you've got building and you've got programming. Okay, and then thrown into that, there are constraints. All right. Your robot can't be too big. Your robot can't be too heavy. Those are the engineering things. And then there's the risks. Your robot, if it travels too far, it might become inaccurate. So it needs to re-situate itself. It needs to know where it is. Okay. And so as we're going along in this unit, maybe a question you'll learn is, okay, so what are the risks? What are the constraints? Why can't you do it bigger? Why can't you do it smaller? One of the biggest constraints is we don't have any pieces. So, and building smaller robots, that takes skill. Okay. All right. So we always have a goal, and we ask, okay, so what is the problem? All right. And how have other people approached it? And what are the constraints? Just ask these questions and questions and questions. And then we can start imagining some solutions. Most teams always have some drama to say, okay, if it's an arm, and if we must push it, we must pull it, we must sweep it, we must lift it. Okay, so they'll always explain somehow with their hands or in dramatic form. Okay, diagrams are always good. You make a list of what do you think we need, a beams and we need an axle, but we might need a So you always have a plan, and then you've got to create it, and then you've got to prove it. So tell me, what does it work? Does it not work? Could it work better? And then you modify the design. And of course, everybody has to test. And testing is actually quite important, because then you realize how can you improve it. Okay, you test to improve. All right, and if you get an error earlier rather than later, then so be it. Okay, all right. So we need to be the design of your attachments can be modified. Okay, so if it's a smaller thing, you take a smaller thing. If it's a bigger thing, then you modify it and you make it a bigger structure. Whatever the function is of the attachment. Okay, there are a lot of examples. Okay, and you need to, from that, you select what you need. Okay, but first and foremost, you need to think of the verb. So what do you push? Do you pull? Do you collect? Do you deliver? You lift? You drop? You fetch? And that is where this problem solving is developed, where you can look at a problem and say, what are we doing? Okay, so we need to collect something. All right, we need to collect it. How are we going to collect it? We're going to make a bumper like this. Okay, that's going to collect it. Okay, what do we need to do? We need to separate a whole lot of things. Then we'll need a plow like this. So then we get the pieces and we build a plow like that. Okay, but remember, these are only passive attachments. So the passive attachments, okay, so this is my trigger. So we're going to drop something. We need to drop the ball into the bucket. Okay, so the robot will then move forward. The trigger, the pivot will trigger, and it touches the side of the container. All right, there it goes. It touches there and it drops it in. Oh no. Okay, so let's just go here. You will obviously have to test it, because if this thing is too short, it's going to go right over the lid of the bucket. Or if the bucket is lower, it's just going to go right over. Okay, so there's your one constraint. Okay, the other one is that this whole structure needs to be above the opening of the bucket. If it's lower and you tip it, it's not going to go in. Okay, it's missed the point. I'll tell you another one, but it's just irritating. Sometimes you get really cheap ping pong balls. Okay, and if you make this thing quite high and you drop it into a lower container, it's going to bounce. It's going to jump right out. It's like, all right. These are all the constraints that you do need to consider. Okay, so cool. All right, next one. So this is quite a simple plow, but if you had a plow like that, you might lose your items. But if you have it like this, then you kind of contain it, because now for this one, you are gathering it. So you either have to deliver to push, or you've got to go and fetch it and bring it back. Okay, and you see you can use exactly the same thing. So either we're going to go forward and push it in the front of the robot, or we can go round. We've got them there, and then we kind of circle over it, and then we bring it back. Okay, so we can collect and push. Whatever way, we can do that. Then there's a gate. Oh, I really need to clean up this box. Okay, so otherwise we can have a gate. Maybe I'll show you later, but you can see the gate has got locks here. All right, so what you would do is then you would go over and the gate would lift up. But when you reverse, the gate is locked, so it can't go out. So this is a really cool thing for collecting jelly tots. So you go over, it'll go in, it'll go in, it'll lift up, jelly tots will go in. But once you reverse it, the locks are there, so it's not going to be able to get out. Okay. All right. So these are really cool structures, and getting your learners to look at something and say, okay, how do you build that? How are we going to build that? And let them look and say, okay, we can build it, but then how to attach it, all right? And ideally, your attachments need to be attached quickly and removed quickly. Remember, we want a multifunctional robot, so we need to attach and remove very quickly. The carabiner is that hook that you use especially when you go mountain climbing. It usually works much quicker with an elastic, but this one hasn't got an elastic. But nonetheless, so if you have a loop, I have a loop. Oh, there we go. All right, so if you were to pick up this basket and you would click it on here, then you'll hold it like that, okay? And so then you can collect your basket. Nice basket. All right. A fork. It's got 4 prongs. That's for collecting something, all right? It always is difficult if you have just 2 prongs and you might miss it. And so you need to work out the constraints. Maybe it is more reliable to have 4 prongs on your fork. Okay. That's our pivot. That's the little structure I showed you now, where you attach it like this and then you tip it like this. For any size, but this will also need to be adjusted depending on what you've got. Okay, that's the gate structure. And thanks to Casper for all these nice diagrams. There's a hook, all right? So either a fork that'll just collect something, or the hook will just bring something back, okay? There's a delivery box that looks like a more straightforward delivery box. There's your bumper, but if you put it like that, then it becomes a collect, so a sweep. If you put it like that on your robot, it's the plow, okay? So when you design attachments, you must have a clear idea of what you're going to actually do, all right? So if the learners know what they're doing, let them follow building instructions, because they know what they have to do, and then you say this is a building instruction, and it's fast and it's straightforward, but it's not theirs, okay? But you use it to build a frame of reference, okay? Whereas the other one is if you just say, all right, build it yourself, which is great for creativity and building it, but you must know that your learners are capable of doing that, because it's going to be their design. And also don't rush them. It's very time consuming, and they probably will reinvent the wheel a couple of times, but that's fine because you need them to expand their creativity. All right. So if you look in your overview document for Unit 4, there are a whole lot of models that you need to build. Okay, a bumper, a delivery box, the trigger, which I've just shown you, the box trap, the sweep, the hook, and the carabiner. Okay. May I ask that you build each one of them, build each model. If you somebody's unmuted. Somebody muted. Thank you very much. Build each of the models. Build each of the models with your learners, or if you don't have learners with you, build each of them so that you have an example of what you're talking about. Okay, and it's good examples. And unfortunately, I have misplaced my book that I wanted to show you, but I'll find another one. I must just go look in my bookcase. All right. There are gazillion little building instructions for things that you can build. It's all part of developing a frame of reference. Even on the Riley rover, it's got, and hasn't got any passive attachments. No, it hasn't got passive. It's just got powered. But you will find building instructions for these. Okay. You have to actually build. So I want you to build it. And then when you've built it, you need to attach it to your robot. And you actually need to program the robot to do something with it. Okay. So push something with a bumper. Push something with a delivery box. Dump something with a motion trigger. Collect something with a box trap. Collect something with a sweep. Hook something with a hooker. And hook something with a carabiner. Okay, so these are some of the activities that we've put together, and that we will maybe in a workshop we'll explore them. But really, so if you push with a bumper, that's fine. But if you push marshmallows or you push a tin of condensed milk, it's different. Okay, and then if you build a little bridge as well, if it's an incline, that's different. And if you push something on like that astro grass, or you push it on a beautiful clean tile, different thing. And then you've got to, I'm going to sneeze now. Different textures, and good for the different ideas. And then you get the one team to say, okay, so why does your robot sickle on the tile or on the wooden floor or on the carpet? What is it? And it's usually traction and friction. Okay. Then the delivery box. If you have a delivery box and you push it, you've got to be very careful. I mean, this one's got a frame to it, but otherwise the box will go into the wheels, and then, the box will then go into the wheels, and then it's just total chaos. Okay, so that is all part of the constraints that you need to do. Okay, dump with a motion trigger. I told you the trigger needs to be the right height. This thing needs to be the right height. The obstacle needs to go in. And pausing, there's momentum. There's really momentum. So your robot must pause before reversing. It can't just go and then reverse. With a box trap, the trap must actually enclose the items. It can't collect things that are too big for it. The sweep, it must have the power to sweep the items. Hook, with the hook, you must be very careful that you actually approach it accurately. And the carabiner is also accuracy. Okay. So designing attachments, there's the Lego Digital Designer and also the Bricklink Studio. But your learners will start designing these most amazing attachments, all right? And you want to keep their designs. So you do want to keep their designs so that you can re-engineer it or reverse engineer it and use it. It's always heartbreaking if as a group of learners have now designed this beautiful thing, and then you need the pieces again. So capture it in the Bricklink Studio, and then you keep it for building instructions. And with that, I'm saying that Casper, we will need to do a Bricklink Studio workshop again soon. All right.
Okay, Dr. Gous.
Noted. All right. So my winning design book, that's what now I've misplaced. I don't know where it is. That refers to passive and powered attachments. There is one for the NXT robot. And then when EV3 came out in 2013, I then bought this book. I haven't seen the Spike Prime version of that yet, so I'm hoping they're going to bring it out. But it is a really good book to read from cover to cover, to kind of put you in the zone, as it were, to understand what's going on. All right. The other one that I usually use, but these are mostly powered attachments, is the EV3 Ideas book. And it builds a whole lot of contraptions. You have a whole lot of pieces. The cool thing about this book also is that the learners then get to choose the pieces. Well, they've got to get, there's no words. So you get a list of pieces you need. I'm kind of thinking of laminating this book because I don't think it's going to stay beautiful for very long. Okay, but it's got a lot of ideas, a lot of things, and the symbol here, it's called No Starch Press. That's where I get most of my books from. Okay, and I get no commission on that. All right, so passive attachments, no programming is required, but it allows the robot to have functionality, and it should be easy to pin on and pin off. So we rather don't build in the powered attachment to the robot, we pin it on and pin it off, and so it comes off easily. And the examples are then the bumper, the plow, the container, and the hook. All right. Where do you get instructions? Well, there's a lot of instructions. Okay, so, oops, sorry. EV3 Lessons has got some passive attachments as a PDF document, which you can use. Attachments for a competition. There's a video you can watch. But here's the other thing, all right? So these are just 2 random videos, okay? But if you watch them, get your learners to identify where are the passive attachments. I mean, once we've done powered attachments, they can identify that as well. But where are the passive attachments used, and where are the attachments used, and what is the verb, and why do they need it? And so this is part of learning, is not just building, but being able to identify what they're doing. Okay, and I guess it's time to build. But that is the end of Unit 4. I'm going to pause a minute and ask, are there any questions? Any questions anybody wants to ask? Anybody? It really is amazing to see what attachments, by the way. So I've got a whole box of these here. Maybe I'm going to have to bend down every time, but even this is an attachment, and you think it had to deliver something. We had to deliver something in one of the competitions. It is straightforward, but it is functional. It gets where it wants to get, and I see somebody spilled coffee on it. Oh my goodness. But it's a passive attachment. It's functional. All right. This one, just get this one out. So this one was a really complex one, and I did figure out how to use it. But you know what happens with kids, and they become very clever. Then they, I will figure this out by next time. So we had to deliver things, and so basically there was a trigger. All right, so it had to go somewhere and deliver something and then reverse. And now I need to figure out what it is. You see, these are clever children but it was all guide. So these 2 were used as a guide to go around something and then to a pole, and this was used to deliver the, there's something missing here. It's definitely something missing. It's not only me. Okay, I'll figure this one out for next time. Okay, but that is also a passive attachment. And there's the trigger. It's just an elastic band. Okay, there's the trigger part. Okay. Also just pivots. And last but not least, this attachment, it looks very weird, but it had to push something down. And it was this way. But it had a counterweight on it because it was quite far. And so to balance it on the robot, we needed to put a counterweight on it. So we used that there. I will also add that the learners, if they get really clever, they design the most amazing attachments. Okay. And the rest are powered attachments. Yeah. What do I mean by clip on and clip off? I just want to show you as well. So this was one of the parts of this attachment here. So it really just, you can see it clips in, and then we used it. There we go. We used it for something, and then when it came back to base, then we took it off like that. All right. I really encourage you also to watch some First Lego League Challenge videos and just see the attachments that learners are building. And please I know you'll be wowed, but just to kind of remember that all learners started in lesson 1, building attachments. Okay, and we build little passive attachments. Even if we build them like this, we build passive attachments first and foremost. And this one, okay, this is just your trigger motion. Some of them are building instructions and others are from the learners, and then they work it out. They design it either with their hands or with their imagination, or in the Lego Brickling Studio, putting things together to say, how will it work and how will it not work?